Hello, today we are going to be looking at our Unit 2 CUME review. For our first four problems, insert grouping symbols to make the number sentences true. Now the trick or the strategy that I like to use here is don't focus so much on multiplication and division signs. Let's first look at our addition and subtraction signs and start there first. So what we're looking at is we need to put parentheses. So grouping symbols could be parentheses, or a squared off parenthesis is known as a bracket. That kind of says, hey, you must do this first, and that works with the order of operations. So number one, it says 160 divided by 16 plus 4 equals 8. We need to figure out how to make this a true statement. So if we look just starting left to right, we'll check that first. 160 divided by 16 is 10. Well, 10 plus 4 doesn't give me 8. So now we will look at the addition, and I'm going to look at this. We're going to look at 16 plus 4. If I do that first, that's 20. And 160 divided by 20 is an extended math fact, and that does indeed equal 8. So again, that goes back to my suggestion. If we really look at the addition and subtraction first, a lot of times we can kind of outsmart the problem. And with the order of operations, that's where we need to put those grouping symbols. So number 2, 2 plus 7 times 6 divided by 2 equals 27. So first, like I mentioned, let's start with the addition. If I do this first, 2 plus 7. Now 2 plus 7 is 9. Now if I do 2 plus 7 times, which is 9. 9 times 6 is 54. 54 divided by 2 is 3. 54 divided by 2 is 27. Sorry, I was already thinking of another way to think through this. So we could just put parentheses with the 2 plus 7, and it will actually work. When we do 9 times 6 is 54. If we divide that by 2, we get 27. Now, other students may feel comfortable. You could do this, and it makes the numbers a little friendlier, and it actually becomes 9 times 3 equals 27. That's a math problem we're more comfortable with and that we more commonly work with. Number 3, 10 equals 90 divided by 19 minus 10. Like I mentioned, let's use that strategy. Let's look at our subtraction and addition first. In this case, we just have subtraction. 19 minus 10 is 9. If I do 90 divided by 9, I do get 10. Now, some people are weirded out that the 10 is on the left side of the problem, so we could just, if it helps you could think of it that way. 90 divided by 9 equals 10, and we could put the equal sign on the right side. It means the same thing. We didn't change the problem. All right, and our final one, wow, we have 156 equals 21 plus 5 times 6. Well, the good news is we only have 2 options of how to group these together. And just to double check, because this seems pretty tricky, if I do this part first, that would be 30. And 30 plus 21 is 51, so we're pretty short there. So we're not going to look at doing the 5 times 6 first. We should look at the 21 plus 5 first. Now 21 plus 5 gives us 26. And when you multiply that by 6, this is tricky enough. We'll actually have to show some work here. And if I do that work, we get 6 times 6 is 36. Carry my 3. 6 times 2 is 12, plus 3 more is 15. And if you look, check it out, we got it right, and that would be 156. Let's look at number 5. We need to write each expression in the correct column. And I'm actually going to tweak that a little bit. And I'm going to letter them to make it a little easier. We're going to call this A, B, C, D, E, and F. Now, my next thing I would like to point out here, if you look, they have a number in common. All of these share the same math problem, kind of the root of the problem. 13 plus 6, 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 and 13 plus 6. All right, so all 6 of these problems focus around what we're doing to the 13 plus 6. And if you look in our chart, 13 plus 6 and 13 plus 6. Now, in our first column here on the left, this symbol here means greater than, which another thing, or another way to think of it, means that we're making our answer bigger than the original 13 plus 6. And on the other side, it's just the opposite. We are taking 13 plus 6, and this means less than, or we're making it smaller. Now, if we stop for a second and think about that, this becomes a lot simpler than it originally looks here. If we're going to make something bigger, the first thing I think of is you're going to add to it, all right? And speed adding, or what we commonly call multiplication. If you think of it, multiplication is just speed adding. So both addition and multiplication are going to make our answers bigger, at least in this case. There are some exceptions, but for now, that's a perfect way to describe it. And the operations that will typically make it smaller, I think of taking from something, which is subtraction and speed subtraction, or dividing something, you're splitting it into smaller groups. That's going to make it smaller. So if we focus on the operations of the problems, we kind of already figured out a way to answer each of these. So for letter A, we are multiplying. So multiplying is going to make it bigger. So I can write A in this box because of the multiplication. For B, I'm taking my 13 plus 6, and I'm taking away from it, taking 5 away from it. So we are making it smaller, so I'm going to stick that over in the smaller column. And then C, I'm dividing my original 19 into 2 equal groups, so that's definitely shrinking it down. Letter D, looks like that's an addition problem there. It's a little blurry. And even if it's not, we're just going to go ahead and go with that is an addition sign for plus 13 plus 6. So I'm going to say that that then made it bigger if that is a plus. E, we are multiplying by 7, so we are going to be increasing that 13 plus 6. And the final one, we are taking 7 away, which is going to make it smaller. So, did you need to evaluate the expression to solve problem A, why or why not? Now, first we have to figure out what the question is asking. Do you need to evaluate? Another way to think of evaluate, which would be solve. If you're not sure what that means, another synonym could be, did you need to answer the expression? We could call that the math problem. I guess I don't have to write it twice. So, depending on which word I just realized how silly this is going to sound. Do you need to solve the math problem to solve problem A? I guess that's all right. Or we could say, did you need to answer the math problem to solve problem A? And if you look at letter A, not problem A, we are focusing on this. So if I write it down here, we are looking at 3 times 13 plus 6. Now, they gave us a clue. They're trying to make us or help us realize that we do not need to. All right, we don't need to. Now, could we? Could we type all these math problems in, see what they equal? Absolutely. That's a safe way, but that way is going to take a little bit longer. So if we stop and think about it, the question we're wondering is, are we making 13 plus 6, are we making 13 plus 6 bigger or smaller? Well, when we multiply by 3, we are increasing the size or making it bigger because we're taking 3 13 plus 6s. So I'm going to go ahead and write. All right, magically my answer just appeared. It was going to be a little bit easier to do it this way. So the first part in pink, I restated the problem. That's a very good strategy to use. So the first part is I did answer, we do not need to evaluate. So I basically said, we don't need to evaluate the expressions to solve problem A because multiplying an amount by 3 will make the amount bigger. And that's really what this problem was to do for us, is to help us realize that and to help us avoid, or hopefully avoid, solving all those different problems, because some of those are going to get a little tricky to do, and the division and the multiplication, it's going to involve a little bit of work. So again, if to make the amount bigger, okay, to make the amount bigger here, as I use my lightsaber, we can add and multiply, which will increase our amount here in this example. And with our example, if we're trying to make it smaller, we're trying to shrink our original amount of 13 plus 6, we would use subtraction or division to do so.